Right, so we're going to look at map scale factor on a map. Two neighboring towns are 3.5 centimeters apart. The actual straight line distance between the two towns is 45 miles. What is the scale of the map? How do we do that? Right, so we talk about 3.5 centimeters. We're going to write the ratio of that dealing 45 miles. Well, mine says 3.5 centimeters. Hold on to that, you'll use it later. Then you'll simplify the fraction. Simplify the fraction, what does that give you? 1 centimeter to what? Does it simplify that far? It won't. So we'll say 3.5 centimeters to 45 miles. Scales are always written using the ratio of something to something else. If it did simplify, since they're both divisible by 0.5, you could have probably done that, but we'll see what happens later on. Sales tax, you plan on purchasing a new vehicle. Recently, a friend bought a vehicle and paid an additional something in sales tax. Assuming the same sales tax rate applies, how much should you expect to pay in sales tax? Okay, so let's figure out first the sales tax your friend paid. What would be the ratio that we'd set up to figure out that sales tax? Probably put your sales tax on top, so it'd be 1650 divided by this much, which would give you some sort of percentage. This actually tell you your sales percent. So please calculate that. What do you guys get as a sales percent? Okay, which what that means is 8.25% as sales tax, which is it's pretty average, I would think, in the United States. I know like up at Chipman Road, that area there, it's like 9% or something like that. I know in some places in the town it's like 7%, so it sounds like that's pretty average. If your car is less than this, it's only 18.5. You're going to pay 8.25% sales tax. Your answer at the very end should be a little bit less than 1650. So all I would do, take 1850 times 0.0825, and you should get your answer should be less than 1650. Okay, it is money. So when we do this, you guys get 15, 26, 25. So again, the idea behind this is you're putting the tax over the amount. Okay, what that does, it tells you your ratio as a percentage of what your tax rate is, and you could actually use that tax rate later. Does that make sense? So you're putting the lesser number over that one. Okay, hopefully you're taking good notes on this. Scale model, this seems really similar to that tank that we did the other day. You purchase a scale model of a car. The model states the scale. Again, notice scale factor 1 inch to 2.2 feet. If the model is 7 inches long, what's the actual car length? So again, we're going to say 1 inch to 2.2 feet. So that's using the scale. And what do we know? Does the 7 inches go on top or bottom? Top, because we have 1 inch on top, so we'll have 7 inches on top, and there's the X. What we'll do is we'll cross multiply and then divide. So the actual car length, what did you guys get? Yeah, so 15.4. What would the units be? Definitely have to be feet. We're talking about an actual car. It's not going to be a little bit over a foot. It's going to be 15 feet long. Says the actual height of the car is 4.5 feet. How tall is the model? Again, we'll set up using the scale that it gave us. We just have to be mindful if it says that the actual is 4.5 feet, does that go on top or bottom? Bottom, yeah, 4.5 feet on the bottom, feet with feet, and now our x is on top. Again, we'll cross multiply and divide. Kind of a weird number. We'll round to the nearest hundredth on this one, I guess. How tall is the model? Yeah, 2.0, and if we were to round 2.05 inches tall, 2.05. You want to represent that decimal somehow. I know it's not the best way to represent it, but it's one way. Questions on that? Okay. Mexican pesos. In November 2005, the exchange rate of Mexican pesos to US dollars was 10.77 to 1. Okay, 10.77 what? To 1 what? Okay, in here it does say Mexican pesos to US dollars, so that'd be the 10.77 to 1. So which is the 10.77? Is that pesos or is it dollars? Pesos, okay. While on vacation, you paid 150 pesos for a basket at a gift shop. What was the price in American money? So again, we're writing 10.77 to 1. This is kind of like dollars. This is the pesos. So if they paid 150 pesos, that goes up top. And you're trying to figure out the bottom one. To the nearest penny, how much did the fruit basket cost? 13.90 what? 93, because you're running the nearest penny. You got to make sure to round that up. Okay. If the exchange rate were this many Mexican pesos to US dollars, what would the cost have been in US dollars? So it's using the same problem, just like, hey, the exchange rate is different. Pesos to $1, well, dollar, I guess I can write it this way. Okay. And again, you paid 150 pesos. Because honestly, the rate changes at least once a day. Depends on a lot of different things, but it changes more than once a day. If their prices stay the same, how much does that basket cost you now? Yeah, so 17.54, round to the nearest penny is what your answer would be. Same basket, same gifts inside of it, same everything else. All that changes is the international rate, which deals with either the inflation of our money or the deflation of our money, or whichever way it goes. So lots of things can happen. I've traveled to a lot of different countries, and honestly, that can kind of get you sometimes. Some days there's really good exchange rates, or some places they'll give you a worse exchange rate if it's really, really convenient to exchange there. Like if you're at an airport, never exchange money at an airport, because you usually pay larger fees and stuff like that, because it's really convenient to exchange money there. The idea is you exchange just whatever you need. You wait till you get to wherever you are going, and you walk around a little bit and you find better places for exchange rates. Generally speaking, banks are better, and some banks are better than other banks for giving exchange rates when you're in other countries. So what was that? Right, yeah. So exchange houses would be places to go. Some countries have all sorts of different things to try. Sometimes there's just like an ATM, and sometimes works out well and sometimes it's not. Depends on what the rate that they want to give you. Canadian dollars. In November 2005, the exchange rate for the Canadian dollars, is this like the same thing? Can we skip it? Canadian dollars is going to be about the same thing, right? Okay, sweet. Swimming pool. The community park has a rectangular garden enclosed by a rectangular fence for protection. The shape of the garden is similar to the shape of the fence. Ooh, the word similar. That's good. That's what we're talking about this chapter. The garden is 60 feet wide. The fence is 70 feet wide and 150 feet long. So let me maybe draw this. Is that we have some sort of rectangle. There's some rectangle inside of it. They're similar. Okay. If our garden is 60 feet wide, this guy was 75 feet wide, and this was 100. Well, this is kind of weird. 150 feet. I didn't really draw it to scale. Whoops. 150 feet. You can kind of imagine. We're looking at how. We're first off looking at what is the scale factor of the garden to the fence. Okay, how do we figure that out? Okay, so the garden would be the 60 that's on top, 60 feet. To the fence is the 75. So it looks like this. Those numbers are all divisible by 15. So that'd be 4 over 5, or scale factor 4 to 5. So then what is the length of the garden? If we do 4/5 using our scale factor, we know that the length of the fence is going to be 150 feet. We're solving for that guy right there. Should probably be 120. Again, I'm making sure to have units with this when you cross multiply. Should get 120 feet. Is that okay? Don't have any questions so far on any of the problems we've done or one we skipped? We okay? All right. Flagpole. That's good. In order to estimate the height of a flagpole, because you can't really just go out there and use a ruler for a flagpole, you can't measure it. In order to estimate the height of a flagpole, a 66-inch tall male student stands so the tip of his shadow coincides with the tip of the flagpole's shadow. His shadow is 48 inches long, and the shadow of the flagpole is 72 inches long. This scenario results in two similar triangles. Draw the diagram of the situation. So here's the deal. There's a flagpole that we don't know how tall it is. I'll just put a little tip on it. Maybe I'll draw a little flag up here, something like this. It's waving. There it is. It's a flag. Maybe there's some stripes on it, something like this. Here we go. Stars and stripes. Okay, flag. Here's the ground. Because the sun's up here somewhere, there's going to be a shadow that's created that looks kind of like, we'll just picture, there's the shadow of the flagpole. Is that okay? You kind of get the idea. It kind of looks dumb. Then what happens is there's a student right here who's standing up. Hey, I'm a student. And he has a shadow as well, and his shadow goes right to there. Okay? What happens is there's actually triangles that are created that look basically just like this. One is just a little bit smaller than the other, exactly the same size, or I'm sorry, exactly the same shape, just a little bit smaller. They are right triangles. Both of them will have a right angle here if we look at it. Okay? What we know about the triangles, let me just draw this other one over here. Like so. This is the smaller one, obviously. What we know is everything in inches. This person over here, he's 66 inches tall. His shadow is 48. Yeah, these numbers are all over the place. We know this shadow over here is 72, and we don't know the height of the flagpole. Okay, does this make sense how to set this up? Okay, I really think that drawing pictures is a really good way to do this, just so you can kind of see what's related. If these are similar triangles, 48 is obviously related with the 72. The 66 is related with this unknown quantity, the h. So the first thing it says, using the similar triangles, write a proportion that models the situation. So what we could do is we could say, 48 over 72 equals 66 over h. There's lots of other ways you could have written that, but you are comparing similar pieces of it. What is the height in feet of the flagpole? So what we'll do is we'll actually cross multiply. We'll have 48h equals whatever 72 times 66 is, and we'll solve for h. You guys go ahead and do that really fast. Okay. I got h equals 99 inches. Is that what you guys got? Is that the answer? No. It definitely says in feet. So again, we know that there are 12 inches in a foot, so what we need to do then is just divide this by 12. So 99 divided by 12 gives us 8.25 feet. It's a very short flagpole of 8.25 feet. It's very short. It would fit in this room, probably. Very close. I bet it would fit in here. Would be okay. Okay? Okay, flagpole problems are really familiar to a lot of people. You will see these next year. If you take Algebra 2, you'll see them that year. If you were to take pre-calculus, you'd see a whole bunch of them then. Calculus, you see flagpole problems there. Flagpoles are basically an essential way of talking about similarity. And probably in Algebra, Geometry 1, if you had me for sure, we talked about flagpole problems as well in there. So something to look forward to. Is this different? Okay, instead of a flagpole, there's a tree. And instead there's a person here. It's basically the same concept that you're looking at the height of the person versus the height of the tree. You're looking at the distance from a mirror to either the person or the tree. It's the same thing. It's just another way that you can do this. This is really hard. I tried this in one of my classes to actually do this. What you do is you actually set a little mirror on the ground, and basically you adjust the person so the person at your eye level can actually see the very top of whatever the object is. Well, what's weird is like I'm 6'3", so 75 inches tall, but that's up here. My eye level is right here. So it's very strange because then I have to like measure like how tall is it from the ground to my eyeballs. And then, because that's where I'm seeing the reflection and going to the top. So it's kind of strange. It doesn't necessarily work the greatest, but we'll see if they take into account that. It says, a pine tree. In order to estimate the height of a tall pine tree, a student passes a mirror on the, or places the mirror on the ground and stands where she can see the top of the tree, okay, as shown. The student is 5'5" tall. Really what this should say is that her eye level is 5.5 feet. And she stands 2.5 feet from the mirror, okay, so that's labeled on there, which is 12 feet from the base of the tree. So the idea is that you can measure this 2.5, you can measure the 5.5, you can measure the 12, you just can't get a ruler out and actually measure the height of the tree, okay? So it's actually called indirect measurement because you can't actually take a ruler and measure the height of the tree. Says what is the height in feet of the pine tree? Okay, why don't you guys solve this on your own, set it up and solve it on your own. I want us to be able to make sure that you guys can do this. You're setting up some sort of ratio between the person and the pine tree. The way I think about this is I think you're talking about the height of something in comparison to the distance it is from the mirror. You're dealing with two objects. You're dealing with the person, and then you're going to deal with the tree. So how tall is the person? Well, she's 5.5 feet. How far is she from it? She's 2.5 feet. What's the height of the tree? Well, I don't know. And how far is the tree from it? Well, it's 12 feet. Okay, so that's the way that I would set it up. You can set it up a lot of different ways. You're still going to get the same answer. That's the way that I think about it. Doing this, I don't know where to write this, but 26.4 feet tall. Is that where we're at? Everybody get 26.4? Okay, sounds good. It says another student wants to see the top of the tree. The other student is 5.5 feet tall. If the mirror is to remain 3 feet from the student's feet, how far from the base of the tree should the mirror be placed? It's kind of a weird deal. you have the same height of a student, but maybe they have different posture. Okay, that's kind of the weird thing, is because you think the tree grows straight up and down. Maybe if someone sort of is leaning forward, they have to, if they're always leaning forward a little bit, like some people do this. I don't know if you've noticed, but some people, they lean slightly forward or they lean slightly back. I'm not sure if you've ever noticed that, but some people do that. That must be what's going on here, because you can imagine if there's a mirror on the ground and you lean forward, you're going to see something different than if you're leaning back, right? So kind of a weird deal. You have this a student who's the same height, but something slightly different is going on. So we'll set up this. This is 5.5 over 3 is going to still equal h. I'm sorry. We know how tall the tree is. This tree is 26.4 feet. And we're trying to actually find now the distance that the mirror should be placed from the tree. Okay, so now we're kind of looking for something that's slightly different. What did you guys get as an answer for that distance? 14.4 feet. Again, I think it's good to have the units on there as we go along. Are you guys taking good notes on this? Okay, hopefully this makes good sense to you. Is this the last one? Okay. Indirect measurement. The last things that we have been doing have all been indirect measurement, because you're not actually being able to measure the tree. You're not actually able to measure the flagpole. It says a painter is preparing an estimate to paint a building. To approximate the building's height, he stands at the tip of his shadow coincides with that of the building. The painter is 6.2 feet tall. His shadow is 3.5 feet long. The shadow of the building is 80 feet long. Draw a diagram of the situation. Okay, go ahead and draw the diagram of the situation. I don't know what your building wants to look like. I have no idea. There's plenty of room at the bottom for you guys to draw that. By the way, this method never works on a cloudy day. If it's a cloudy day, you don't have shadows, so you can't really do it. Okay. So hopefully you've already drawn this building. Oops, 80 feet. Okay, so we're looking at some sort of triangle that looks like this. Okay, hopefully you're able to set this thing up. Again, we'll look at sort of a ratio of height of whatever we're talking about to the distance, or actually this is the length of the shadow, sorry. So we're talking about two things. We're talking about the person. The person's 6.2 feet tall. They're 3.5 feet from the shadow, or that's how long their shadow is. We don't know how high the building is. We know their shadow is 80 feet, which is pretty big. Part B, it says the painter's partner is standing in the sun. She is 5.8 feet tall. How long is her shadow? We'll basically use just either one of the ratios. It doesn't make a whole lot of difference. I'll just pick his shadow, and we'll figure out how long her shadow is, something like that, S for shadow. There's going to be a lot of decimals in this one. We'll see how this turns out. Her shadow would then be 3.27 feet. something like that. Okay. So these are the problems that we're looking at. Lots of story problems. Your homework is going to be pretty much just as long. Really similar. Sometimes instead of a car problem, there might be like a subway or a train. Instead of something like buildings, there might be trees or something specific. Again, these are the problems. I hope that you took good notes on them because they're going to relate directly to what we're talking about on your homework as well. If you guys have questions with your homework, please let me know. I do want to help you.